Hello everyone, welcome back to our channel. Today we are diving into a crucial component of industrial automation and control panels, circuit breakers. If you're an engineer, technician, or just curious about how electrical systems work, types of circuit breakers frequently used in the control and automation industry. Let's get started. So, what is a circuit breaker? First things first, what exactly is a circuit breaker? In simple terms, a circuit breaker is an automatic switch that protects electrical circuits from overloads or short circuits. They act as a safety mechanism, interrupting the flow of electricity when a fault is detected, preventing damage to equipment and reducing fire hazards risks. Now, let's explore some common types of circuit breakers used in industrial automation and control panel. So the first one is MCB, miniature circuit breakers. MCBs are used for low voltage circuits and they are most common type in both residential and commercial applications. They automatically switch off when an overload or short circuit occurs, protecting wiring and appliances. If an excessive amount of current passes through a cable, this cable will eventually heat up and cause a fire. Thus, overheating properties of an MCB is used to prevent the fire. However, the overheat reaction is not instant. It can take some few seconds. Overcurrent is when there is a short circuit and massive amount of current flows. The circuit will trip and stop this overcurrent to protect our devices and equipment. They are used for switching on or off as well. Their rated current is up to 100 amps maximum. MCBs come in single pole, dipole, or tripole. For double and triple, each phase line is connected in each own pole. Now we go to the second type of circuit breaker. So we have what is called the molded case circuit breakers, MCCB. These MCCBs, their rated current is much higher than the MCBs. They are rated up to 1,000 amps. MCCBs are usually for medium voltage applications and are capable of handling and interrupting higher fault currents than MCBs. They are used as the input power switch of large electrical panels. They come with adjustable trip settings, making them versatile for various applications. You can adjust the current at which you want the MCB to trip. For example, you can say for this particular system, I want the MCCB to trip at maybe 135 amps or 500 amps. We will talk more about MCCBs when we do the calculations and the selection. The third type of circuit breaker that we have is called an earth leakage circuit breaker. Earth leakage circuit breakers protect against earth faults by detecting leakage current to the ground. They are essential for enhancing safety in environments where direct contact with electrical installations can occur. They detect any smaller current leakages and trips instantly. They are usually used at the input of an electrical panel, and these ones they are often used in the main distribution panel that will be feeding your control panel, and it is connected in series with the main panel circuit breaker. The earth leakage circuit breaker are connected to the phases, the neutral and the earth, so that they can be able to sense if there is a leakage that is occurring by comparing the three phases and the return neutral. The last type that we're going to look at today is the residual current circuit breakers, RCCB. This one is similar to an earth leakage current circuit breaker. RCCBs detect differences in the current between live and neutral wires. They are critical for preventing electrical shocks, but they do not provide protection against overloads. Hence, they are usually used alongside MCBs or MCCBs. How do you choose the right circuit breaker for your control panel design? Here are a few key factors to consider. Number one, the rated current. Ensure the breaker can handle the maximum load of your application. So usually when you are designing a control panel, you will start with your VMI, that's valve, motor, and instrument list. Then from that VMI, you then generate a load schedule. So from your load schedule, this is where you know for this particular type of panel that you want, what's the total load that you have in terms of current. Then using those loads, you use them to then size circuit breakers. Then the other thing that you also need to consider is the braking capacity. Check the breaker's ability to handle fault currents. Then the other thing that you need to know is to also know the tripping characteristics. So your selection should be based on the specific needs of your equipment, whether you require instantaneous tripping or a delayed tripping. Then the other factor that you can also consider is the environmental conditions. You have to consider the temperature, humidity, dust levels, and so on of your installation sites. All these they determine the selection of circuit breaker. Lastly, then for the installation and maintenance tips, always ensure power is off before working on any electrical equipment. You need to follow the manufacturer's guidelines for installation procedures and also test the tripping mechanism periodically to ensure they function properly. And that's a wrap to our guide to circuit breakers in control panel and industrial automation. These devices play a significant role in maintaining safety in electrical systems. If you found this video helpful, give us a thumbs up. Thanks for watching. We'll see you in the next video where we'll be talking about contactors and relays.